In this problem, we are thinking about apples and pies. How many apples should the students pack into each bin? They have 1,065 apples for baking apple pies. The apples need to be split evenly into 25 bins. So we have some things here. We have some givens. They are telling us how many apples we have in total. They're telling us how many bins we have to split it into. What we're trying to figure out, though, our goal is to figure out how many apples should the students pack into each bin. So we'll be solving for the number of apples in each bin. So we're starting with 1,065 apples, and we are dividing them evenly into 25 bins to find the number of apples, A, in each bin. So let's get started. We're going to solve this problem two different ways. We're going to first use the traditional algorithm for division, and then we'll use the partial quotient method so that you can see how the two relate. Let's get started with the traditional algorithm. We have a dividend of 1,065. The 25, or the number of bins that we are dividing those apples into, is our divisor. And we're going to be finding our quotient, the number of apples in each bin. So to use the traditional algorithm, we start by asking a question about that divisor. We're asking, can I pull any groups of 25 out of, and this is going to seem strange, 1? And I know that that 1 really represents a 1,000, but when we use the traditional algorithm, we're going to think about it this way. It's kind of a trick. So no, I can't pull a group of 25 out of 1. We move over a digit. Can I pull a group of 25 out of 10? No, I cannot. Can I pull a group of 25 out of 106? Well, yes, I can. So that tells us that the first digit we record in our quotient is going to go right above the 6. So we're going to estimate how many groups of 25 can we pull out of 106. Well, I know how to count by 25s because I think of quarters. So 25, 50, 75, 100. I can pull 4 groups of 25 out of 106. Next, we multiply the 4 by this 25, our divisor. And we're going to record the answer right under the 106. So 4 times 25 is 100. And now we're going to subtract. 106 minus 100 is 6. And now we are going to, see this 5 here in the ones column? We're going to pull that 5 down and turn the 6 into a 65. And we're going to ask the question again. Can I pull any groups of 25 out of 65? Yes, I can. How many? 25, 50, 75. Just 2. So I'm going to record the 2 here, and now multiply 2 times 25, which is 50, and subtract. 5 minus 0 is 5. 6 minus 5 is 1. Now, we don't have any more numbers here to pull down, as you can see. So 15 is less than 25. I certainly can't pull another group of 25 apples out. So this is what's left over, or our remainder. And depending on the story problem, we think about how to talk about that remainder. But in this particular problem, our remainder is apples. So the solution to our problem is 42 apples fit evenly in each of the 25 bins, with a remainder of 15 apples that we'll need to think about how to manage because they're apples. Do we want to chop them up and give parts of apples to each bin? I'm not sure about that. Who knows how long the apples will be sitting before they get turned into pies. Maybe we'll keep them on the side, but when we answer a situational story problem, we need to make sense of the remainder. So let's take a look at the partial quotient method and how we could use that method to solve the same division problem. In this strategy, we're still going to be pulling groups of 25 out of our dividend of 1,065. We can pull them out in any way we'd like, though. So my 25 table I know pretty well. But I also know that 10 groups of 25 is 250. And there are definitely more than 250 apples in here, right? There's over 1,000. So I can double that. So if 10 groups of 25 is 250, 20 groups of 25 is 500. I'm going to start right there. And I'll pull 500 apples out of the total. And I'll be left with 565. That's really easy subtraction for me. I like when that happens. And there's room for me to take another 20 right out. So I'll pull another 20 groups of 25 apples out, also known as 500 apples. And I'll be left with 65 apples after I subtract. So I can pull, let's see, one group would be 25, 2 is 50, 3 is 75. So I can pull 2 more groups of 25 apples out, or 50 apples. And I could be pulling out any number of groups. I could pull one group of 25 out over and over and over again. I'd be here all day, but I could do it. If I'm really comfortable multiplying by 10, I could do 10 groups of 25, 250. It would take a little longer, but my answer would come out the same, and that's all that matters. So this strategy is about maximizing the facts that you know well. So can I pull another group of 25 out of this 15? No, I can't. So how many groups was I able to pull out? Well, that is right here. I pulled out 20 groups, then another 20, so that's 40, then 2 more. So I pulled out 42 groups of 25 apples, and then I still have 15 apples left over. So we got the same answer 2 different ways.